In the last video, we created this grid list that keeps track of all of the information about the tiles on our Tetris grid. It has 22 rows for the 22 rows on the grid, as well as 10 columns, and each grid space in our list stores a number that represents which type of tile is saved there, which type of piece this tile came from. You can see that we also have the grid, the values of the grid, rendered onto the screen using this sort of pen system we've come up with to draw everything so that the player can see what's going on behind the scenes. So this list is really good for storing information about pieces that have already fallen and gotten locked into place. The problem is that it's not very good for storing information about a piece that's currently falling. If we have a falling piece that the player wants to be able to control, and its 4 tiles were saved into this list, imagine trying to move the piece when the player hits the right or left arrow keys. It would be quite a challenge to figure out exactly how this grid list should change. So instead of saving the falling piece in this grid list, we're going to create some new variables and some new pieces of information about the falling piece that we can use to save it separately. So I'm going to create 4 variables here. One is going to be the piece x. This will be the left x coordinate on the grid of the piece. We'll also create the piece y. And so with these two, we'll know the x and y coordinates on the grid of the top left of the piece. We'll also do the piece rotation, how far the player has turned it right or left, as well as, very importantly, the piece type, which shape of Tetris piece it is. So in theory, these 4 variables are enough information to know the exact coordinates of every tile that make up the Tetris piece. The problem is that actually figuring that out, if we wanted to, for example, draw the piece onto the screen, actually figuring out what those coordinates are is not super easy. It's definitely possible. This is enough information to do it, as long as our code understands sort of what the Tetris pieces look like and how they work, but it's still going to be a bit of a process. So in order to help us out, I'm going to create a custom block, and what this custom block is going to do is it's going to get the piece coordinates. It's going to say, given this x, y, rotation, and type information, and we'll run without screen refresh on this, given that information, I want to get the coordinates. I want to get the x and y coordinates on the grid of the 4 different tiles that make up the piece. So for example, if I had a long piece, an eye shape, this cyan color, and that was the type, and the rotation was maybe horizontal. I don't know how we're going to represent that in data yet, but if it was a horizontal piece, and the x was maybe 1, so it's on the left, and the y was 22, so it's on the bottom, this piece would give us sort of the 4 x and y coordinates going along the bottom left edge of the screen. So that's what we want this piece to do, and in order to do that, we need to create some lists. I'm going to create 2 of them. One will be the piece coordinate x, or maybe we'll call it the piece tiles x, because these are the 4 tiles that make up the piece. And we'll do the piece tiles y as well. Piece tiles y, both of which are for this sprite only, although again it's not a huge deal either way. So we have piece tiles x and piece tiles y. I'm going to put them down here. They'll cover up a little bit of the board, but that's probably all right for now. Piece tiles x and piece tiles y. And the idea is that this custom block, when you run it, will clear out these lists and then add 4 items to each. So you have 4 points, which are the 4 tiles that make up each Tetris piece. So in order to do this, we could use some if statements. We could say, if the rotation is one thing and the type is another thing, then we know what the coordinates will be. And we'll try that to start, although I suspect that we will want to do this a little bit differently once we figure out what we're doing. So let's imagine that the type is 1 and the rotation is 0. And I have over here the super rotation system, which is sort of one of the systems that people use to rotate Tetris pieces. And so you can see this is all 28 combinations of different piece types and rotations, and it shows what their coordinates should be. So right now, we're doing piece type of 1, which is the cyan eye piece, and the rotation of our piece is 0, which I'll just say is this far left rotation column. And so what we want to do is sort of create this piece in the top left. So this piece has like the bounding box. The box going around it has a width and height of 4. We're just going to treat this top left square as 0, 0. And then if you go to the right, 1, 2, or 3, that's your x going up, and down is your y. And a positive y will go down in this case. So this will be a y of 1, y of 2, y of 3. So if we want to store this information here about piece type 1 and rotation 0, we're going to add some information to the piece tiles x and piece tiles y. And so we're going to add 4 different numbers, right? Right now they're just thing, but essentially we have, or 4 different, I guess I should say points, 4 different coordinates, because there are 4 tiles that make up this piece. So the first one that we're going to do is an x of 0, because it's on the far left, and a y of 1. That's this far left tile here. So I'm going to add an x of 0 and a y of 1. Then we want to have an x of 1 and a y of 1. Then an x of 2 and a y of 1. Then an x of 3 and a y of 1. Of course, our y is always 1 because it's perfectly horizontal, but the x changes. It goes from 0 to 1 to 2 to 3. So if we did this, this would give us, when we run it, let's say that we want to get the piece coordinates at the top left for the rotation of 0. We haven't rotated the piece at all, and it's piece type 1, the eyepiece. If we do that, it'll give us the coordinates that we need. The problem here is that it doesn't account for the x and the y that we type in. So if we type, an x of 5 and a y of 15, nothing changes. Oh, I did forget to clear out the lists at the beginning. We'll start by deleting all of the items in the list. But as you can see, when we run this, we still have x of 0, 1, 2, and 3, and y of 1. So this x and y don't really matter. But they should. And so what we're going to do is add a little bit of math in, where we say, like, well, rather than 0, it should be 0, but then add in whatever actual top left x we really want. So we'll make this be 0 plus x. And of course, you could just plug x in there, but we'll kind of try to be consistent with all of these. Here we have a y of 1, but then we actually want to add in whatever the piece's y is. So we have a y of 1 because it's down from the very top of this little mini grid, but then we also want to add in the positioning of that mini grid in the larger game. All right, then we can do kind of the same thing where we can say an x of 1 and a y of 1 plus whatever the coordinates are. Then we can do x of 2, y of 1, and then x of 3, y of 1. And again, all of these now are going to take into account the x and y coordinates of the piece. So now if we get piece coordinates, you can see that we have an x of 5, 6, 7, and 8. So the left x is 5. That's what we told it to be. We plugged in that x value. But then it knows, well, the piece is horizontal. It's going across. And so we'll start at 5, but then we'll have 6, 7, and 8 as the other x coordinates as well. Then we said we're at 15, but it plugs in 16 as the y because this piece is sort of 1 down from the very top row. So that's really good. And we could continue to do this. We could sort of duplicate this and create 28 of these giant if statements, one for each of the pieces in this entire grid of options. But you can imagine, we just have 2 here, and it already takes up more than my entire screen. If we had 28 of these, it would be very bulky. It'd be a lot of code. And so I'm thinking maybe there's a better way that we can store this information. Because if you think about it, there's really not that much that changes between each if statement. We have the piece type, the piece rotation, and then these 8 numbers here, and that's all that actually changes. So I'm thinking rather than storing all this information in code, what if we could store this information in a list? We could create a list, and maybe we'll call it piece templates. And the idea with this list is that it never changes. We can manually type some information in here and use this list as a storage space for all these numbers that we care about. But then while the game is playing, the list never changes. We never add or remove items from the list. It just is used as sort of a way of storing information that's a little bit cleaner than trying to store it in these giant blocks. So how would we do that? How would we take all of this information and turn it into a list item? Well, I think it's actually pretty straightforward if we think about it. We can just take these 8 numbers. We can go 0, 1, 1, 1, 2, 1, 3, 1. And so I was just reading down here, and we can turn that into a list item. So now this one list item, if we write some code that understands it, this one list item can represent one of the piece types on this grid. So we can just create 28 of these little template strings, and as long as we can write code that does 2 things, we'll succeed. All we need is code that can understand a list item, and also code that can find the right list item to use in the first place. So let's start by doing the understanding of the list item. If we just say item 1 of piece templates is the template that we're going to use for now. In the future, we'll use the rotation and type variables to figure out which of these templates to use. But for now, we're just going to say the piece template that we are choosing to use is, whoops, not a cloud variable, for this sprite only. We're going to make our piece template be just the first one in the list. We're just going to get the first one, and later on, again, as I said, we'll use the rotation and type to figure out which template to grab. But for now, we'll just grab number 1, and then we want to use it. And all we have to do is, rather than having these numbers sort of plugged in manually, we can pull them from the list. So we say, first, take letter 1 of our template, and when we say letter, that's actually a number. It's just going to be this first digit here. So this 0 is going to be letter 1, and that's going to get plugged in. Then we're going to plug in letter 2 of our template. And I think you can see how this is going to go. Then we get letter 3 and letter 4 and so on. And now, no matter what our template is, we can read it and store it into the list, the 2 piece tiles X and piece tiles Y lists. So if we do this, now every single time we run this block, it will grab a piece template number 1 and then use it to fill in these 2 lists. So it looks kind of like nothing has changed, but the benefit here is that we can just create our piece templates rather than creating separate if statements for every combination of rotation and type. So let's try writing a few more templates here. We've got this first one. Now we want to do the second one, and we're going to try to do this all in one go. We know that all of our x coordinates should be not 0, not 1, but 2. Every single one of our x's should be 2 because it's vertical. But then the y is going to start at 0 and then go down to 1 and then 2 and 3. So we're just going xy, xy, xy over and over again. So our x, as always, is 2. Then our y is 0. Then our x is 2 and our y is 1. Then our x is 2 and our y is 2. Then our x is 2 and our y is 3. So there we go. We just put another template in. And the problem is that our code doesn't actually use this template yet. But we'll fix that in a minute. So I'm going to go through and keep adding these templates. And maybe I'll fast forward through some of it and keep you around for the interesting bits. But it's going to take a little bit of time. But once we're done, we'll be able to use these templates to fill in these 2 lists. All right, so I'm doing piece number 3. So it's going to be x of 0, y of 2, x of 1, y of 2, x of 2, y of 2, x of 3, y of 2. Then we have x of 1, y of 0, x of 1, y of 1, 1, 2, 1, 3. All right, now we're at a piece that has a width of 3 and a height of 3, but really nothing changes. We can put these sort of x and y coordinates in any order. Our code won't care. So I'm just going to start with the top left one here, which is 0, 0. And then we want to go down. We want to go to the piece below. So I'm going to add this tile in as an x of 0 and a y of 1. And then we want to go to the right and to the right again. So instead of 0, 1, it's going to be 1, 1, and then 2, 1. So there we go. Those are the coordinates for this piece. And I'll continue. Now we want, we want 2, 0, 1, 0, 1, 1, and 1, 2. Then we want number 7, 4, 5, 6, 7 is going to be 0, 1, 1, 1, 2, 1, 2, 2. Number 8 is going to be, 1, 0, 1, 1, 1, 2, 0, 2. All right, number 9. Hang on. I just realized we do have one problem here, which is that the templates in this list, in this image, are in a different order than we have in our code. So in our code, we have something a little different going on. We have cyan, then yellow, then purple, then green, then red, then blue, then orange as the order that the pieces go in. So actually, we started with cyan because it was at the top of this image, but that's okay because that is type number 1. But for the code that we're going to write later that grabs the correct template from the list, we need these to happen sort of in order. So we need number 5 here to be the yellow pieces now. So I'm going to jump down to the square, and I'm going to be writing templates for that. So we'll put these all in order. All right, we did it. That's 1 through 28, all of the piece templates in order. And the order here, just to be clear, is that we have the first 4 being the cyan piece, piece number 1, and it's each of the 4 rotations in order, kind of rotating clockwise, the same as they were from left to right in this image. Then numbers 5 through 8 are yellow, numbers 9 through 12 are purple, and so on. And so what we want to do now is just write some code that can grab the correct template from the list. So given this rotation and this type, we should be able to figure out not just grabbing item 1, not just getting the first template, but getting the correct template. So we know that there are 4 different templates for each type, which means that if our type increases by 1, the list item that we're accessing should increase by 4. So what I'm going to do is I'm going to take the type and I'm going to multiply it by 4. But this does give us a bit of a problem because we start at type number 1, and if we take 1 and multiply it by 4, that means we're starting at list item number 4. We don't want that, so instead of making type start at number 1, I'm going to subtract 1 from it. So it's kind of like type starts at 0. So it'll go 0, 4, 8, and so on. Then we want to add in the rotation. The rotation is easy because when it goes up by 1, we should increase the list item that we access by 1. So we'll just plug that in. And now the only problem we have left is that type minus 1 starts at 0 and counts up, and rotation starts at 0 and counts up. Remember, rotation goes 0 through 3. And so if we plug in a type of 1 and a rotation of 0, we'll end up trying to grab list item number 0. And lists in Scratch don't start from 0, they start from 1. So we're just going to add 1 to this entire thing and sort of shift everything down a little bit. And with this little formula, we should always be grabbing the right template for the piece. So let's try this out. Let's get some piece coordinates and see if this is working. I guess I already have a block down here. This one should still be the same. Yep, we click this and these 2 lists haven't changed. But imagine that we had a rotated piece. If we take the same still piece type 1, but now it's rotated. We're looking at this version right here, so it should be sort of vertical, starting 2 to the right of the x that we asked for. So we asked for an x of 5, but we get an x of 7. That's good. And we ask for a y of 15, but it starts at 15 and then counts down. So that's good. That means that this piece template is working. What if we tried a different piece type? If we try piece type 4, what one is that? 4 is green, so we're asking for the green piece, and we'll ask for rotation number 3. So we're trying to get this shape right here. And maybe just to make it simple, we'll start at 1, 1. So can we get this shape where it goes kind of down and then to the right and then down again? If we ask for that shape, we get an x of 1, y of 1, so that's the top left. Then an x of 1, y of 2, which means we went down a square. That's right, we went down. Then we ask for x of 2, y of 2, which means we went right a square. And then we get x of 2, y of 3, which means we went down a square. So that's good, we went down, right, and down. And it's starting at 1, 1, which is the top left coordinates that we asked for. We could type in 4, 4, and it'll add 3 to each of these, going from 1 to 4. There we go. And so unless I made a mistake in one of these templates, which is totally possible, it seems like our code is working. So the last thing that I want to do is try to use this to actually draw a falling piece onto the screen. So I'm going to hide our templates list here. And we're just going to say, let's actually draw this piece. And it should be pretty straightforward because we don't actually have to do a lot of work. We already have this render tile block, and that pretty much does everything we need. So inside of our main render grid, we are going to get the coordinates of the falling piece. And in order to do that, we're going to plug in all of our different variables. We created our piece x, piece y, piece rotation, and piece type. And we're just going to plug all those in. And we're going to say, get for me these two lists, right? The coordinates, the 4 x and y coordinates for the piece based on these 4 variables. And then once we do that, we just need to draw it. So we have this list, and we just need to draw those 4 spots onto the grid. So I'm going to make a variable that I want to have be sort of a counter that just counts from 1 to 4 so that we can get each list item in order. And I'll just call it n. That's often a variable name that I use for counting. You could call it whatever you want, though. So we start with n at 1, and then we want to repeat 4 times. So we're going over each of the 4 coordinates for the tiles. And we'll change n by 1 so that above this item, or above this block, whatever we put in there, we'll run once with an n of 1, run again with an n of 2, run again with an n of 3, and then with an n of 4. And all we really want to do is render the particular tile that we have at that position. So we know what the x is going to be. The x that we want to draw is going to be coming from this piece tiles x list. That's the whole reason we created it, is that so that we know the coordinate that we want. And we are getting item n of piece tiles x, as well as item n of piece tiles y, and that'll make us sort of loop through each of them. Then the last thing we need is which type of piece we want to render. That goes in this final blank. And the piece type is easy because it comes from this variable. So if we set our variables, our falling piece information, piece x, piece y, piece rotation, and piece type, we should be able to render that block, that falling piece, onto the screen. Now, I'm just going to change these sliders. That's a good thing to know you can do. I'm going to make the x go from 1 to, let's see, I guess 7 is probably the maximum that makes sense. And the y, the top y is going to be 1, and the bottom y is going to be probably about 20 or so, makes sense. Our piece rotation, I'll let it go from 0 to 3. And our piece type, I'll let it go from 1 to 7. All right, there we go. So we have our sliders, and we should now be able to draw. Yeah, look at this. So I have our piece here, and you can see I can change the x and y. I can change the piece type, and I can change the piece rotation, and all of these work. So let's try going through every combination of type and rotation. So piece type 1 seems to be good. Those rotations all look good. This is just to check that I typed all the templates correctly. Piece type 2 should never change, even when you rotate it. Piece type 3, let's see. That looks good. All of those look correct. Piece type 4 looks good. Piece type 5 looks good. And then piece type 6 looks good, and piece type 7 looks good. All right, so by some miracle, I actually typed all of the templates right. That's very lucky. But as you can see, we now have the ability to draw this falling piece onto the screen. So in the next video, we're going to actually manipulate this falling piece. We'll make it so it really does fall, and the player really can control it. And then we'll make those pieces lock into this grid and show up using the grid list that we created earlier. So we're well on our way to creating a Tetris game. I'm feeling pretty good about this, and I'm excited for the next video.